In section 1.3, we're going to be working with writing expressions. And what we want to make sure that we're able to do is translate verbal phrases into algebraic expressions. So basically, when we're talking about verbal phrases, we're talking about descriptions of situations. And how do we turn that into math equations that we can use? So key vocabulary for this section is going to be verbal model, rate, and unit rate. Okay, so if we look at the idea behind what we're doing here, when we're talking about the vocabulary of addition, they're going to be using words like sum, plus, total, more than, increased by. So we might have a verbal phrase like the sum of 2 and a number x, and that would become this expression, 2 plus x. A number n plus 7 becomes n plus 7. When we're talking subtraction, the vocabulary would be difference, less than, minus, decreased by. So the difference of a number n and 6, that's going to be n minus 6. A number y minus 5 becomes y minus 5. The vocabulary with multiplication would be times, product, multiplied by, of, like 12 of something. So 12 times a number y becomes 12y. 1/3 of a number x becomes 1/3 x. And finally, for division, we have quotient divided by, divided into, and that would look like the quotient of a number k and 2. That would be k divided by 2, or it could be the ratio of a number k and 2, k divided by 2. Okay, when we do a little practice on our own, so 5 more, right? More is important. That's going to become addition. Then 3 times, that's going to be multiplication, a number w. So that's going to be 3 times w plus 5. 5 more, here's the 5 more, then 3 times a number w. 3 times w plus 5. The product, that's going to be multiplication, of 6 and a number y. So that's 6 times y. Okay, so it's important as you're working, especially with word problems, that as you're working with what the situation, how the situation is being described, that you can accurately put it into an algebraic expression which you can later use and or solve. Okay, so a number of hours, the number of hours in m minutes. Well, hours relates to minutes. There's 60 minutes in an hour. So I could say it would be 1 over 60, 1 hour per 60 minutes, times m, or I could say m divided by 60. The amount of money you spend if you buy a shirt for $20 and jeans for $J, well, the and is going to become addition, so I have $20 and $J, so it's going to be J plus 20. Okay, now here's a situation we're going camping. The rental cost of a campsite is $25 plus, right, that's going to be plus, $2 per person. Now per, $2 per person, that's going to be times. It's going to be $2 times each person. Write an expression for the total cost. Find the total cost for 5 people. So I know I have $2 times the number of people plus the $25. Dollars and dollars. Now if I want to find the total cost for 5 people, I plug the 5 in here, plus $25. I'll have $10 plus $25, so the total is $35. Okay, now we're talking about rates and unit rate. A rate is a fraction that compares two quantities measured in different units. We do a lot of that. Miles per hour, dollars per hour, those are rates. If the denominator of the fraction is 1 unit, then the rate is called a unit rate. So if I want to find the unit rate, remember it's the denominator is 1 unit. Okay, so for me to make the denominator of this fraction be 1 unit, I actually have to do the division. So I'll have 171 divided by 3. So 3 goes into 17 5 times. So this becomes 57. Right? So I know that that would become 57 miles per hour. But the problem is they want it in feet per second. So if I want to convert from miles per hour to feet per second, I know that I've got to go from miles to feet, and I have to go from hours to seconds. So when you start thinking of these things, I know that I have 5,280 feet in 1 mile. These are unit rates, right? I know that I have 60 minutes in 1 hour. And I know that I have 60 seconds in 1 minute. So if I want to start using these ratios to convert from miles per hour to feet per second, one of the things that I can do to help guide me through that is just look at the units of measure, because I can put these ratios together either way. I don't know what goes in the numerator. Do feet go in the numerator, or do miles go in the numerator? Each one of these could be arranged either way. So if I just take a look at the units of measure, miles per hour, now I need to end up in, where I'm headed is in feet per second. So I need to put feet into the numerator. You see, I've got miles in the numerator now. I need feet in the numerator. So if I do feet per mile, then the miles will cancel and I'll be in feet per hour. Okay, so I need to have seconds in the denominator. So what I'm going to have to do is I'm going to have to put hours in the numerator. So if I do hours per minute and then minutes per second, then the hours will cancel with the hours, the minutes will cancel with the minutes, and I'll end up in feet per second, which is what I want. So if I start off with 57 miles per hour, then I can multiply that times 5,280 feet per mile, and then I could do my hours and minutes, so I can do 1 hour, 60 minutes, and then I have minutes over seconds, so that's 1 minute over 60 seconds, and this will get me where I need to go. Okay, equally I could have done, you can see that if I combine these two, in fact maybe I should have done that, I could equally have said, well, if there are 60 seconds in a minute and 60 minutes in an hour, then it's 3,600 seconds in an hour. I could have done that. So to simplify that a little, 57 miles per hour times 5,280 feet in 1 mile times 1 hour and 3,600 seconds. So if you look at this, the miles will cancel, the hours will cancel, and I'll end up in feet per second. If I go ahead and finish out this fraction, I should have no trouble. So I'm going to do my numerators together. So 57 times 5,280, 300, 960. So I'll have 300, 960 feet divided by, the denominators are 1 times 1 times 3,600, so 3,600 seconds. So now but we want to get to a unit rate, so I have to divide by 3,600, and I get 83.6. So it becomes 83.6 feet per second, and that is our unit rate. Okay, what the big takeaway here for you is when you have conversions to do like this, and you're questioning how to arrange them, what goes in the numerator and what goes in the denominator, if you track your units of measure, you can be sure that you're arranging your fractions correctly so that you can get the proper unit of measure when you finish. This is also something as you move forward in your academic career and you start studying chemistry, you'll do the same sort of thing when you're working with stoichiometry in chemistry. So file this away in the back of your head. Remember this when you get into the chemistry class. You're going to want to be remembering this idea in terms of how you arrange your converting ratios. Okay, one final example here. For a training program, each day I run a given distance and then I walk to cool down. One day I run 2 miles and then walk for 20 minutes at a rate of 0.1 miles per 100 seconds. What total distance do I cover? So I'll have 2 miles plus 20 minutes at 0.1 miles per 100 seconds. So that's a difficult unit of measure. So do I want seconds or do I want minutes? So it's going to become interesting as I go through doing this. I need to find a total distance, so I need to finish up in miles, right? So what I'm going to need to do is I'm going to need to convert. I can convert these to seconds. That's probably going to be the best thing, and then I'll get my miles. So when I do 20 minutes, I'll have 20 minutes times 60 seconds in a minute, right? Seconds. This was minutes. Let me start this over again so I can write better. So I'm going to have 20 minutes times 60 seconds in a minute times the rate, which would be 0.1 miles per 100 seconds. Okay, and you look at how this is going to cancel out. The minutes are going to cancel with the minutes. The seconds will cancel with the seconds. And I'll end up in miles. That's what I want. Okay, so if I go ahead and work with this fraction, now again, I can multiply out my numerators. So I'm going to have 20 times 60, so that's 1,200. The 2 miles isn't going to change. I'm going to have 1,200 divided by 100 to become my miles. Times 0.1, I'm sorry. Times 0.1 is going to move my decimal place. So it becomes 120, right? So 20 times 60 times 0.1. Sorry, I forgot the 0.1. 20 times 60 times 0.1 is the same as 20 times 6. So that's 120 divided by 100. And that's 1.2 miles. So my total was 3.2 miles.